So, hello, I am Shoptak Dash, data science intern in Exposys Data Lab Bangalore. So, our today's topic is about the most chronic disease. This is diabetes, which affects millions of people worldwide. And this disease of basically two types. In type 1, our body can't able to generate insulin properly. And in type 2, our body generates insulin properly, but our body can't use that insulin effectively. That's why we suffer from this disease. In this diabetes, blood sugar level are effectively increased, that is threatening to our health. And if we can detect this diabetes early, as soon as possible, the chance of become a victim through this disease is less. So in this model, we are going to discuss about this process, that how we can detect the diabetes so that precaution can done by the patient in prior. So here is our model, basically used by Python. We run this model in Google Colab, and as you see in the screen, that first we import NumPy, Pandas, MATLAB and Skin Matrix, and if we run this, it takes some time. So our import is done properly, and now our main data set, which is a huge data set that we have to train our model by this data set. So we have to mount this data set in our system, and here is the data set that I previously loaded in my files in the sample. And so here is the dataset file. We have to mount it, and we mount our dataset perfectly in our model. And if we run this, you can see that our dataset run perfectly without any error. And next, in the model, we have to run this section, that is parameters, glucose, blood pressures, skin thickness, insulin, BMI level on the basis of our data set. And if we run this section, it runs properly, and we can see that the column, that is glucose, blood pressure, skin thickness, insulin, BMI, and the count of that data types. And here is the data type int 64, and some BMI is float type we consider. And after that, yeah, here we have to run this section. Then we have run this, and it successfully runs about the outcomes of this section, the previous section. And here is the logistic regression formula we have to implement our model by this algorithm at first. So if we run this section, it successfully runs, and here is the logistic regression function call we consider here. And we have to found the total cost through this algorithm. And if we run this section, it runs properly, and it print the value of the previous section, that is 532.337. We have clearly seen. Now the gradient logistic part we have to run for showing the performance of that model with respect to cost. And we run this model, and it runs properly. Here the array values, after running, it is successfully runs, and these values are printed successfully. So here the updated parameters are run successfully. I previously run this, so here in this screen you can see that. And here the final curve, that is cost versus iteration curve. Mm, here some problem happens, sorry for that. So I previously don't run that section, sorry about that. We have to run this section properly, because otherwise the curve will be not shown in the screen. Just iteration part must be run properly, and it runs one by one. You can see it takes some time. So we can clearly see that the total iterations and cost are printed in our screen. So after that, the prediction and target value we have to show, and here the section is run perfectly and the prediction target values are one by one printed in our screen. And now we print this section, that our curve that runs successfully, and we can see our cost versus iteration curve as it starting and it ending. After some hindrance it runs properly, and we can calculate or detect the cost with respect to our iteration step. Now we calculate the classification matrix that we have written in this section, and if we run this, if one score put successfully in the screen, and now we have to plot the predictions, that is glucose level, blood pressure, and something parameters. And on the basis of the previous cost graph and the previous dataset that we have mounted in this model, the diabetes level versus glucose, blood pressure, skin thickness, that is chances of diabetes with respect to these parameters are shown through a graph in our screen. Now we set this model and logistic regression function call, and it runs properly. We run one by one the rest portion, and we can see the accuracy level clearly, right? It's the so for this is the implementation of one algorithm in the model, but we have to determine more models, otherwise we can't judge that which model performs the best with respect to the diabetes detection, right? So we have to implement some more algorithm like KNN, discrete matrix, and some others algorithm that we implement one by one. And this features section we have to run perfectly one more time, and we have to normalize the data that runs successfully. And this is the logistic curve that we previously runs, and this is the KNN classification, KNN algorithm we have run successfully. After that, SVM classification model, then decision tree matrix we have run successfully, and linear regression model. This, apart from logistic regression, we also implement these four algorithms in this model, and after that we evaluate the models, and then we see which model performs the best and gives the accurate result for the detection of diabetes. So evaluate model, we can evaluate here that section. We have to run this, and we have run this. So each model, if we run, so there is some error. Sorry, we did not run the logistic regression part here. We have to run it first. It takes some time. And you can see that it runs perfectly. And now the all algorithms, all code section, that is logistic regression, KNN, classification, SVM, decision tree, linear regression, all runs perfectly. We evaluate the model, and now each model evaluation, and we can see that the performance of all models are printed here. And if you see this result perfectly, then you can see that among the all models, decision tree matrix shows the highest F1 score and accuracy level compared to other algorithms. So we can conclude that, as we see, decision tree matrix shows the best performance with respect to F1 score and accuracy. Hence, decision tree matrix algorithm is the best algorithm for diabetes detection using machine learning. And thank you for trusting us.